layers below, carrying contamination with them. And nobody's exactly sure how much or how fast it's happening. The geological threat isn't abstract or theoretical. It's quantified and documented. Scientists monitoring the lakebed through permanently installed seepage meters found that flux rates decreased on average by 0.021 meters per day per year between 2004 and 2015. That's a 4.5% annual decline in the groundwater discharge rate, a number that might seem small until you realize what it means. Extrapolate that decline over decades, and you're watching a fundamental shift in the lake's hydrological balance. The limestone and dolomite bedrock beneath Lake Michigan dissolves in slightly acidic water. This process accelerates with changes in precipitation patterns and temperature fluctuations, exactly what we're experiencing with climate change. Karst systems on gypsum form and collapse much more rapidly compared to limestone karst, because gypsum is far more soluble in water. Lake Huron, which shares the same geological foundation with Lake Michigan, just 100 miles to the north, shows large springs discharging water saturated with dissolved gypsum, indicating active dissolution is happening right now. This isn't theoretical speculation. This is an ongoing geological process that's fundamentally altering the water supply for millions of Americans. Climate change has weaponized the entire system into a death spiral of water loss. Warmer temperatures drive higher evaporation rates from the lake surface, creating an accelerating cycle that's becoming self-reinforcing. When winter's extremely cold air passes over relatively warm lake water, you get massive evaporation events that strip millions of gallons from the surface in days. Last summer's near-record high lake temperatures, approaching historical highs, produced significant evaporation losses when cold air arrived in the fall. A pattern of dry fall seasons from 2023 to 2025 has been draining the Great Lakes at an accelerated rate, and forecasts from NOAA and the Army Corps of Engineers indicate Lake Michigan will remain 11 to 12 inches below average through at least August 2026. That's not a temporary dip. That's sustained, persistent suppression of an already stressed system. Meanwhile, human demand for water has never been higher. Despite access to Lake Michigan, significant portions of the region, especially those dependent upon groundwater sources rather than surface water, are already encountering water supply and quality issues. Chicago itself faces another layer of vulnerability that few residents understand. The city relies on Lake Michigan for 90% of its drinking water. If Lake Michigan were to become unusable, the city would face catastrophic system failure. But the lake's shoreline is assessed as not supporting primary contact or safe fish consumption due to E. coli, PCBS, and mercury contamination. The treatment plants remove these contaminants before delivery, but as water quality deteriorates and levels drop, the cost of treatment increases exponentially. Every year, the system operates under stress, multiplies the strain on aging infrastructure. But there's another dimension to this crisis that nobody's talking about publicly, and it's potentially more dangerous than the obvious water level decline. The contamination issue runs deeper than surface pollutants. Michigan spent more than $27 million providing affected homeowners with clean public water supply to avoid widespread exposure to TCE, a toxic chemical leaking from a 13 trillion gallon plume of contaminated groundwater. That plume originated from a former chemical handling facility in Mansalona, Michigan, and it's been slowly migrating through the subsurface for decades. Now imagine similar contamination plumes, and there are several more identified plumes in the region, migrating through karst channels toward Lake Michigan at accelerated rates. Groundwater discharge is likely an important vector for contaminants that affect the Great Lakes. The region's groundwater is widely contaminated from failing septic systems, inappropriate application of animal waste and agricultural fertilizers, abandoned industrial sites where chemicals were used and never properly remediated, and leaking landfills. All of this contaminated groundwater is connected to the lake through fractured limestone and dissolved